Now let's get this segment started. We've got pings going between the two. As you see, I put our IP addresses back on router 1, 10.1.1 on the fast Ethernet interface, and then 1.1.1/32 on our loopback. So we're ready to go there. Let's go ahead and have a look at the network command here live. And good idea to have this, of course, memorized for your exam, exactly what they're asking for as we go across. And the first one is the network number, and then it's wildcard bits. So this one's easy to come up with because we want to initialize OSPF on any interface beginning with 10.11 for the first 3 octets, and that's it. So our wildcard here on R5 and R1 will be 000255. We got to set the area ID. As you see, there is no CR there, so this is required. You do have to put the word area. You have the option of putting the area in as a decimal and an IP address. I would just not get cute and just stick it in as a decimal value. And that's it. That's the command. So let's head over to 1. I'll put the exact same command in. And we'll hang around here for a few seconds. We can go ahead and run show IP OSPF neighbor if we want. We're already in two-way state, so that's really good. And notice that under neighbor ID, we do see 5555, which is going to be the OSPF root of router 5. Again, what's the rule? Loop back first, even if it's not OSPF enabled. So we're in two-way state already. And we're going to hang around here. I'm not going to keep scrolling that for you. I know it's like the elevator button. You just keep hitting it. But I'll just go ahead and pause the video for a few seconds while we wait for that to come up, and then we'll examine the command a little more closely. And didn't take long at all. It took about 10-12 seconds there probably. And you can see we've got an adjacency change message, process 1, neighbor 5555, even tells you what interface it's on. And it does say from loading to full, and the loading is done. So that all sounds pretty darn good. Let's run show IP OSPF neighbor again now. And let's go from left to right on this. And we know why the neighbor ID and the address shown are different. Some people don't know that, so you're already ahead of the game. The neighbor ID, of course, is the OSPF RID of this neighbor. That priority refers to the priority on the interface through which the adjacency was formed, and that is 1 by default. The state of the adjacency is full, and this is indicating that the neighbor at 5555 is the designated router. We see full/DR. The dead time is at 34 seconds. We know why, because this is a broadcast segment. 10 seconds hello by default. 4 times that is the dead time by default, which gives us 40 seconds, which means that this value should never fall beneath what? As long as things stay good, it should never go below 30 seconds. So anytime you catch it here, dead time 32, couple seconds later it will have refreshed because a hello would have come in. And we see the address, the remote address through which the adjacency has been formed, and the interface as well with local, which is fast Ethernet 00. So we're good there. Let's go over on router 5, run the same command. And we see exactly what we expect to see. And again, the interface shown here at the end is the local interface through which the adjacency is formed. So you got remote neighbor ID, remote priority, then the state of the adjacency, what the role of that router is, the dead time, the address on the remote device through which the adjacency has been formed, and then the name of the local interface. So, you know, pretty intuitive stuff there with show IP OSPF neighbor. Now I want to use this opportunity to introduce you to another couple of show commands, one of them being show IP OSPF interface. And I think this one gets overlooked quite often. And we're going to go ahead and just hit it there. And you could put the name of the interface after show IP OSPF interface, and you might want to do that, say if you have 4 or 5 or 6 interfaces on your router that are OSPF enabled. But some good information for us here. And first off, it's going to tell you right there's the physical and logical state of the interface. Shows you the IP address of it, what area it's in, of course, helpful information there. So you're gathering some good information up here. There's the process ID, the RID of the local device, the network type, and an Ethernet segment is always going to default to the broadcast network type. That cost is 1. Whenever you hear the word cost referred to in a metric, they're talking about OSPF. And we're going to dig more into that as we go through these labs and after we're done building our network. But that is the cost of this specific interface, and the cost of this interface is 1. There's some information here that you might not use for a while. Topology, MTID, some of this stuff down here I wouldn't be too concerned about. I hate to ever say, hey, this doesn't matter, but it's information you probably won't use all that often. But you can also see, here's the state of the interface. It's the DR. Here's the priority of the interface. Here's the DR and the BDR for that same segment. So of course it's telling us 5555 because we're on router 5, and this is indeed the DR for this segment. Also shows you what your timers are. So a lot of good information here. Here's how long before the next hello is due. And at the very bottom, neighbor count is 1, adjacent neighbor count is 1, even tells you who the neighbor is, and then finally, if that router has a role, either as the DR or the BDR, it's going to tell you what it is right there. A lot of good stuff there, and that's a good command to recognize. If I showed you the output of that, you should be able to say, okay, that's show IP OSPF interface, gig Ethernet 00. Now let's just run plain old show IP OSPF. We ran that earlier when we had our disaster, right? And most of this information you're going to run into in your NP studies and later, but this material at the top here is really good stuff, because here's your process ID, here's your process, here's your RID, here's the start time and the elapsed time from the process actually starting. Most of the material here, not something you're going to use every single day, but I want to show you at the very bottom. It always seems like with these, that the information we really want is at the bottom. This reference bandwidth, we're going to talk about that later. That's an important value, and notice right now it's set to 100 meg. And here's your area backbone, and it's going to tell you how many interfaces you have and if you have authentication set up for it, and if so, what kind. And this is good information to have right here if you're running into issues. These SPF algorithm values, how often it's been executed and when it was last executed. Because as I mentioned from time to time, we have to be detectives in this business. And of course, that goes for the exams too. Because sometimes you're just going to be shown a config or shown information like this, and you're asked, hey, what's going on here? And what's going on here, we see, it's been a little while, not that long, since the SPF algorithm was executed, but it's been executed twice. Nothing really wrong with that. But if that algorithm executed is regularly incrementing, there's some instability in your network somewhere. You may have a flapping link, one that just goes up and goes down, because every time that happens, a router is going to have to recalculate SPF, then recalculate again when it comes up, then recalculate it when it goes down. And just running that command again to get that info at the bottom. I wanted, yep, it's at the bottom. I gotcha. So here it's been executed. Of course, that timer is accruing now, and it's been 5 minutes, 53 seconds, 0.74 milliseconds, and executed 2 times. But if you're doing some troubleshooting with OSPF, whether it's CCNA, CCNP, or otherwise, this is a good one to check and just see if the algorithm is being executed on a regular basis, or if it's incrementing over time, over a few minutes or so. Because if it is, again, you probably have some instability somewhere there in your network. Now, we have enabled OSPF on the 10110 network, and that's it so far. So if I look at the OSPF routing table, not looking at any other kind of routes, and I'll show you how to do that. You do it with show IP route OSPF. What should I expect to see right now? What routes am I going to see with show IP route OSPF? None. And this is a good exam question too, a good practice exam question as well. Got to remember that just because you enable OSPF on an interface that's connected to, a network, whatever network that is, that doesn't mean it's going to show up in the local table as an OSPF route. As a matter of fact, it's probably not. It's going to show up as a connected route, because what you're seeing with show IP route OSPF are routes that OSPF discovered and have been put into the routing table. At this point in our network, OSPF hasn't actually discovered any routes for router 5, because router 5 is directly connected to its own loopback. Router 5 is directly connected to the 10110 network, and we didn't put router 1's loopback in OSPF. So that's why the OSPF routing table is empty right now, even though we have it running and everything's fine with the actual operation of the protocol. The reason we don't see any routes here is that OSPF hasn't discovered any from R5's point of view. I have a feeling that's going to change as we go forward, because what we're heading for next is configuring an NBMA network, and this one has the most details of any of the network segments that we're going to take on. So take a little break if you need to, clear your mind, come on back, and we're going to look at the details for the DR BDR election as well as our hub and spoke network that's going to be part of our NBA network, and that is coming up next.